So now we run the turtlesim node, turtlesim node. So once we do this, once we have a turtlesim generated, so you can see there is a blue screen that actually shows that there is a turtlesim right now. So now once we have the turtlesim, all that we need to do is 1 minute sometimes. Okay, yeah. So now we need to see what information we get from the turtlesim. So in order to find that information, so the information in ROS is sent via things called topics. So we do a ROS topic list, which lists down all the information that is available to us right now. So ROS out and ROS AGG right over here, these two get generated once your ROS core starts running. So those are not information that we need right now. The two most important topics that you are going to be dealing with are turtle1 command velocity, this one, and then turtle1 pose. These two are very important because turtle1 pose actually gives you the position of the turtlebot along with its heading, turtlesim rather, along with its heading. And then turtle1 command velocity is where you actually send in your commanded velocity. You calculate the commanded velocity and turn rate, and then the turtlebot moves to the waypoint, which is your assignment. So now let us look at what this pose topic says. So what is the information contained in the pose topic right now? So for that, if we want to display it to the screen, we just do this ROS topic echo and then turtle1 pose, and you see we get the pose. So it says x is 5.54, y is 5.54, and theta, which is the heading, that is 0. So heading is always measured from the x-axis, and now it is 0. It doesn't have any linear velocity, neither does it have any angular velocity. So those are also 0. So now what we will do is we will try to see what is the structure, like what is the type of these x, y, theta, linear velocity and angular velocity. What is the type of variable that it is. So you can consider a message to be a structure which has different variables inside it. And the topics are just an instance of that structure at one point of time. So to do that, we do something called ROS topic type turtle1 pose, and then this, the pipe operator, and then ROS message show. And now you see that we get the ROS message structure. So what does it say? So x is a float 32 type of variable, y is a float 32, so is theta, angular velocity and linear velocity. So this is the structure that is already made inside ROS. This is a pre-built ROS message, so you don't need to do anything at all with this. You just have to import that in your Python file, something that I will be showing later on. So now what we do is we can also, so this is called a ROS topic type, which is called pose. So now we can look at a ROS topic type. Yeah, my computer is getting a little slow, so just because of the screen recording, so sorry for that. Now if you look at the ROS topic type for command velocity, we see that it has two different parts to it. So the structure is divided into two more substructures. Now it may seem complicated, but you don't have to deal with this. This is all dealt with in ROS. You just have to send proper messages to the proper field. So now it says geometry messages vector 3, so it has 3 elements in the vector, and it is called linear. And then we have geometry messages 3 vector structure, which is angular. So now linear velocity is the linear velocities, it is UVW. So for linear velocities, all that we are worried about right now is just the float 64x. Because this is a 2D vehicle, so we are not considering what will happen to the vehicle in its z-axis. Now we also consider what happens, we have to consider the turn rate of the vehicle. Because the turn rate is important, because that is how the vehicle aligns itself and moves towards the waypoint, something that you will be doing. Again, a lot of big terms, but it is not difficult. We will go through that. So here the only thing, so X, Y and Z are the turn rates. So P, Q, R. So R is the heading turn rate. So for that, when we, so all that we are concerned about in this assignment is float 64x, which is the linear velocity, and float 64z, which is the angular velocity. So now I will run my turtlesim waypoint controller and just show you how these things vary. So now this my okay, and it's in the package called waypoint. So we in ROS run, I should have said this before, it says ROS run, the package name, and then the executable file name. So waypoint and then turtle. Okay, this is extremely slow. This is a turtlesim waypoint, that's the name of my file. So I press an enter to it, and the turtle should be moving. It's just because I'm recording this screen, it's going extremely slow. So what we can do is we can do an echo, and we can look at the command velocity. We can also do split the screen here, and then we can do ROS topic echo turtle1 pose. Okay, now you see that it is almost very close to the waypoint, and we have a buffer zone. So if it reaches the buffer zone, we say that it has reached the waypoint. So you can see it has a different psi value, the heading value, and right now linear and angular velocity have become 0, but they were some values, you saw them in the command velocity, right? So this is all that you need to do for your assignment, and let us go and talk about the waypoint controller in the next video, and then we can see how we can implement that. Okay.